Hello, Keith Rucker here at VintageMachinery.org. Guys, so today we're getting started on a new little project for a viewer, and this is kind of cool. He has sent me a couple of cast iron castings, and what these are for brake shoes for a very unusual and rare vehicle. He has a 1917 American Underslung, a 1914 American Underslung car that he is restoring. American Underslung, this is a really old car manufacturer, kind of back in the, I think they called it the brass era, very early automobile. They only made these vehicles, he told me, between 1907 and 1914. This is when the last year that they were made. He has been working on restoring one of these, and he told me there's only about 30 of them left in existence, but he's been working on restoring one of them for about 15 years. And one of the things that it needed was new brake shoes, or brake drums rather. And he actually had castings made. I don't know the story on where, how, or what, but these are needing to be machined, and I do have a blueprint over here that he provided with me on how these need to be machined out, and we will be basically getting these things turned according to the blueprint. So this will be a project we're going to do over on the big lathe. This is 17 inches in diameter on the very largest diameter on there. A little over that right now because it's rough casting. And there's a lot of machining that goes on this. This is going to be, I don't think it's going to be fully machined, but most surfaces in here are going to end up being machined before it's said and done. So anyway, let's get started on this. We're going to start by getting the backs of these set up over here on the lathe. Let's see, wrong place. There we go. This is just getting it up on here right now. I'm going to have to get this kind of indicated in. I'm sure that's not running true. I don't have any machine surfaces on this to indicate off of, but we're going to try to get this running somewhat true. Right now, all I'm going to be doing is facing this backside, so this is not critical as far as concentricity on the outside. It just needs to be up flat against this, and of course this inside flange is not machined either, so I'm going to be looking for more run out in this way than I am on the outside on this, because like I said, I just need a flat surface back here, and once that's done, we're going to flip this thing around, put it back in here, and start working on the inside. So there we go. That's going to be step one. I am going to put a dial indicator on here, and like I said, it's going to be bouncing all over the place, but we can at least get it close. That's all I want to do, is just get it close. All right, we've got it on there, and it's bouncing all over the place, but there's about 50 thousandths run out, and I think most of it is in one direction. So right here, let's see, that needs to go in. So I think I need to do is come around 180 from that. This needs to come towards me, so I need to loosen this up just a little bit. We're going to go to the other side again. And I need to move it in about 25 thou, which is about right there. So let's see what this looks like now. Some of this is just the irregularities in the casting. I mean, we've still got 25 thou run out. Let's look at this. So that's, I'm going to check them opposite of one another. So that's only about 10, 12 thou out, but that needs to go in. I'm going to just loosen this up ever so slightly. We'll go to the other side, and let's check these two. Go 180. Yeah. All right, this is where we're at. So again, I'm looking at just one side compared to the other. So we're on 0 here. I'm gonna go around to the other side. We're within 2 thou. All right, so the number's off a little bit here, but again, that's just variability in the casting. We'll go 180 to that. And again, we're within, depending on where you put it, I mean, it's jumping around 10 thousandths just on the surface finish. So from the highest to the lowest, I'm seeing about 40 thousandths. But again, that's really just the irregularities in the casting. I'm gonna spin it up. We're gonna look at it spinning and visually look and see if there's any visual run out in it. And if not, we're gonna go ahead and start machining this. All right, I'm just looking at it, and you know, it's definitely got a little bit of wiggle in it, but for a rough casting, that's pretty darn good. I'm mostly looking at this top up here. We're gonna be machining this backside, so we'll be machining most of that out. I'm pretty happy with that. I think we're gonna roll with it. I think we are ready. We're going to start coming in here and just touch off on this. All right, I just got off the phone with the person I'm doing this for, and I had some questions about this little raised area in here. According to the drawing, it just showed a flat face, but then the casting had a little raised area. Turns out he wants that completely cut off, so we're going to get a little more aggressive with our cut here. I was at first just going to get it cleaned up and kind of work off of it from there, but yeah, we got to get it completely taken out. So let's go. I'm going with about a 25 thousandths cut right now, and we're going to machine this thing out. We are moving on here. Should have just one more pass to clean this up. I'm going to do about 15 thousandths and see if that finishes cleaning that up. If not, we'll go back and take a little bit more. But we should have this pretty well turned out. Let's see if that cleans it up. I think that's got it. We'll let that turn on out. It kind of cleaned it up, but I'm going to take this probably another 10 thousandths cleanup pass on this just to get that little, there's a little bit of a, where it took that heavier cut where it didn't, feels like it kind of flexed on me, but we can straighten that out no problem. All right. I think we got that one done on the back side. So I think what I'm going to do before I flip this around and start working on the other side, I'm going to go ahead and get the other one. There's 2 of these to do, so I'm going to go ahead and get the other one. We'll get it to this same point. So I'm going to swap these out, and I'll do the other one, get it ready to roll. Well, guys, I got the backs of both of the drums faced, and we're ready to kind of move on. And I've run into a problem that I was not anticipating. I'm not going to go into a whole lot of details right now because it's probably going to end up being a video on its own sorting this out. But when I got the chuck over here, or the part, and turned around and put into the chuck and started dialing things in, I was noticing, hey, there's some visible run out on that side that I just surfaced, and I started investigating the chuck that I'm using in here, and lo and behold, this chuck has got some run out in it, some run out on the face of the chuck, some run out on the face of the jaws. On on the jaws that we're on down here, it's about 10/1000ths of an inch run out on this face in here. If you go to the face of the chuck, there's about 30/1000ths run out. And what's interesting is every step on the jaws here has a different run out in it. Why? I don't know. You know, this chuck came with this lathe. I haven't used it a whole lot, but when I have used it previously, it's mostly just been chucking something in and running, not facing up against it, which is where my problem is. So what I'm gonna have to do is I'm gonna have to fix this. Now, I can machine the face of this. That's no problem. This is just a cast iron chuck, so I can just put this in the lathe and face it. But these jaws are hardened. They're gonna have to be ground, and probably ground on the lathe to get them right. So unfortunately, I've got to stop right now and deal with the chuck before I can continue on with the project over there. Kind of glad I found this, because this could give me fits on projects down the road. And on this project where everything has to be basically referenced off of that face that we just did, it's going to be critical that we have that right moving forward. So before I go any farther, I am going to take the time. We're going to get this fixed, and then we'll continue on with the project. For you guys, you're going to be able to pick up right where I left off, because I'm going to deal with this in a whole separate video, and then we'll just kind of continue this once we get the chuck problem sorted out. So in the magic of YouTube, we'll be right back. Well, again, like I said, through the magic of video editing, here we are back again. And in the middle of all this, I spent a pretty good bit of time reworking this chuck back here. In fact, you've probably, if you watch the channel regularly, you've seen the video on me tuning this chuck up. In case you didn't, we basically reworked the whole chuck. I refaced the back plate, I refaced the back side of the chuck, we refaced the front side of the chuck, and we ground all of the steps here, the jaws, to get them to the same height. And fortunately, and to my surprise, this chuck turned out better than what I expected. I've now got a flatness on here of around 1/1000th of an inch or less, which is going to be plenty good enough for what we're doing. So I think we are ready to move on. I've got this part chucked back up over here in the lathe. Again, with it being a raw casting, it's not going to run perfectly true until we get things machined, but we are ready to get started working on the inside of this. I think my game plan is I'm going to start by facing the back side of this. We've got to get this inner piece down here to about 200/1000ths thick. Right now it's around 325, so we've got about 125 thou to take off of this face. I'm going to take most of that off. I'm going to probably leave a little bit on there, and then we're going to turn the diameter on the inside here. This has got to be 16 inches across. According to my measurement, we got about 1/2 inch, about 500/1000ths to take out. So we got a good bit of material to take out of this inside face. We've also got to cut this front face here parallel to the back. I think this is 3 inches, and then I think it's 17 inches on the outside of here. We'll get that done. So we're going to be doing a good bit of machining in here, and we should be ready to roll. So let's get at it. I will too say that to do this turning on the inside, instead of using a regular, cutter like you cut on the outside, we're going to be doing it with a boring bar. I got a really thick, heavy, stout boring bar here, and because of we're cutting on inside diameters and inside boring here, having that curved feature down here on the bottom of my cutter, it's just going to work a lot better, and we can do the facing and everything with this tool just the same. All right, let's get at it. All right, here we go. I'm going to come in here. We're going to touch off on the back side back here. I'm just going to take a skim pass. I don't know how much we're going to be cutting there. I'm going to kind of establish where we are. So we're just going to let that kind of work its way out. Touch where it will, and then we'll start on the next pass really making a cut. Anytime I'm working on a rough casting, I kind of like to just do a real skim pass the first one, because I don't know how much variation there is in the thickness in here. So we're just going to take it easy coming out. All right, let's take this first pass, and then we'll start cutting it down. Just giving a quick update here. We are machining away. I about got that inside cleaned up. Let me get an idea of how thick we are here. This is just a rough indication. We should still have, we got about 100 thousandths to take off. I'm more or less cleaned up. I've still got a little bit out here in the edges that we haven't quite touched off yet, but we got plenty of material to take off. Taking about 25 thousandths per pass, and we're going to take another pass through here. Just about to the end of the cut here. I'll stop it when I get right down in the root of that bottom. Watch what cut across. There we go. Well, guys, we've been working along at this brake drum project, and quite honestly, I've hit a pretty serious snags, actually a couple of snags on this project, and it's going to force us to kind of stop in our tracks and reevaluate some things here. Let me show you what's going on. So I have gotten down, I'm trying to get this inner thickness to 200 thousandths, which is mighty thin for a piece of cast iron. I'll stay off the top. But whenever I was coming back in on the last cut or two, I've noticed that once I got into the back and came forward, that my cutter wasn't touching up on the front side up here. It was, I would start a cut, it would cut all the way back, and then I get to the here and come back, and there's a gap here in between. That's a problem. Let me show you another problem that I've seen here. Make sure this thing's in neutral. Right here, there's an inclusion in that casting, a little tiny hole. And for a brake drum, that's not a good thing. Let me show you what has happened. So to further illustrate this, I'm going to take a straight edge and I'm going to put it in here. I'm going to kind of hold it across the hole in the back, and this should be flat. You see that big gap down here? That's about 3/8 of an inch. That was machined flat when we first did this, before we started turning the inside. What has happened is as we have been turning this, because of stresses inside this casting, it has been dishing inwards. There's tension out here on the outside of this. As we're cutting that material out, we're releasing that tension, and probably the inside hole in there has got some tension around it. The tension is different, and it's causing it to bend inwards like that. That is not a good sign whatsoever. So if you notice in that last video clip of us actually cutting, when I was in the back, the tool kind of dragged, and then about halfway down, it quit dragging and then got to the front, and that's when I noticed that gap. I'm like, that should be flat, what's going on? And that's when I got this straight edge out and realized, hey, this is a problem. So I've been back on the phone with the person that I'm doing this job for and talked about a few things, and actually got a little bit more information about some stuff. So a little bit of the story about how this came about. Well, first off, originally when the car was built, the brake drums that were on the car were all made out of pressed steel. So basically it was just a piece of steel that was pressed into a dish. And of course, over the years, they've worn out and whatever. That's the reason he wanted to make new ones. Pressed steel like that, as it heats up and cools down, you're going to get warpage and stuff. Probably wasn't the greatest design in the world, but again, you got to remember this is 1914 the concept of brakes on cars was still at a pretty infancy, so, a lot of technology has gone on over the years. And I think that's what Alan was trying to do, is kind of move it forward, re-engineer this, and have a cast iron drum like you would have on a more modern vehicle. But we go back to some of the issues. This really thin cross section in here, 200 thousandths, it's not a whole lot, particularly with cast iron. Cast iron has a lot of strength and compression, but it is very, very brittle. And when you have a real thin piece like that holding this drum on the outside, I think we've created a situation where we've released a lot of stress and we see the issues. But honestly, I would be concerned on the cast iron backing back here, whether that's even going to hold up over time. And we talked about this and yeah, probably not the greatest thing in the world. I got on the phone with Clark Easterling, my foundry guy, and talked about the problem. He said, well, of course, we don't know the whole story. We know that he had these brake drums. He had a pattern maker up in Ohio, made the patterns, and he sent them off to a foundry up there, had them cast. He has no idea where they were even cast at. But talking with Clark, he feels like that very likely they knocked these out of the molds before it had completely cooled down, and that probably put more stress in it, and they probably were not heat treated, stress relieved. Depending on what kind of work that foundry was doing, stress relief may not be part of what they even do. In a lot of applications, you don't need a stress relief. Something like this, stress relief would be extremely important. So speculating probably was not, but also talking with Clark, and he uses brake rotors as his material that he melts down to cast. And he's told me before, I didn't even think about it, but we came up in our conversation, that he doesn't use brake drums to melt down. And the reason is that most brake drums that are made today actually have a steel back in them. This back piece is steel, it's not cast iron. They take a plate of steel, they put it in the mold, they pour the cast iron around that steel, but you got a steel plate back here, which is a lot stronger in this application than a cast iron backing would be. And yeah, I think that's probably would be a better solution for this. So again, the owner, we've talked about it, we've decided we're stopping right here, we're not gonna go any further, this is not gonna work. It's anytime you're re-engineering something like this, there's a lot of trial and error involved. And in this case, yeah, we tried, he tried, it didn't work. We're gonna have to go to plan B. What plan B is gonna look like, I don't know right now. Again, the person that's doing this project, that's gonna be a decision that he has to make. He is an engineer by training, so it's not something that he's just going into lightly, but now that this problem has been exposed, he can kind of reevaluate. Very well may see this project come up again in the future. They're in the process right now of doing some investigating on how to better make a casting that we can machine so that we can have a cast iron drum rather than a pressed steel drum, which I do agree that the cast iron drum is going to hold up better, be less likely to warp and stuff going forward, but it's got to be done right. And unfortunately, this was not the right answer. So this project, yeah, I don't know if I'm going to call it a failure. It is a failure. I don't know that it's a failure because of the work that I was doing to it. It was more just a failure in the design evolution. But again, when you're reinventing the wheel on any project, you often have to go through iterations, and it's a process of learning. And we learned something here. So it's not all in a wasted time, but a little frustrating that we were not successful. So guys, with that, we're going to cut this video off here. Hope you've enjoyed it. Everything doesn't always come out right. Sometimes you have to back up and punt. This is a back up and punt situation. So anyway, we're going to call it there. As always, thanks so much for watching. Please do subscribe to the channel if you haven't already. Those thumbs up and comments are always greatly appreciated. It really helps feed the algorithms on YouTube. So please do that. Click that thumbs up. Leave the comments down below. Please subscribe if you have not already. And as always, a big, huge thank you to those who support the channel financially through Patreon, PayPal. There's links for that down in the description. That's something you can help out with. It enables me to take the time to shoot the videos, bring them to you, do the editing and everything else that goes along with it. Guys, with that, we're going to get out of here. We'll catch you on the next video again. Thanks for watching.